Welcome, my dear NEET 2027 and 2026 warriors. I hope I'm audible and visible to all of you. Welcome, say hello, say hi, and mark your attendance quickly by smashing that like button in the video and also subscribe to the number one NEET English channel, which is your Vedantu NEET English. So, today we are on to our next lecture of motion in a straight line. Remember, in the previous class, we studied, things going horizontally, car, bus, accelerating, displacement in nth second, using kinematic equations, what is velocity, acceleration, displacement, how to find all of that. So now that we understand these basic concepts of kinematics, let's shift it vertically. So dropping things or throwing things up, how much time, what is the maximum height, and things like that. What speed will it hit the ground? All these kind of questions which are categorized as motion under gravity, vertical motion under gravity. That is what we are going to see. There is a separate lecture just for projectile motion. Okay. Hello everyone. Good evening. Good evening. Good evening. And yes, it's a weekend time, and classes at 6 o'clock for 11th syllabus and class of 12th standard syllabus at 8 o'clock. Remember, all these lectures are open both for NEET 26 and 2027 students. Especially NEET 26 should watch both, and NEET 27 highly recommend to watch the 11th syllabus. Okay, after that you can watch the 12th syllabus. Cool. So let's begin. Mark your attendance, my dear students. Yeah, done, dusted. Subscribe to the channel. Awesome. Let's begin then the class. Ready? Okay. So let's begin with the class and show full energy. And if you've forgotten to like the video, please like it, guys. Many times kids forget. So try to like the video because we put in so much of hard work for all of you. Yeah, smash that like button and also subscribe or else you'll miss all the classes. Remember, 6 o'clock every day, you have the 11th standard batches and 8 o'clock for 12th syllabus. Okay. Now, when we talk about vertical motion under gravity or free fall motion, this word free fall should not be, confused for something else. Free falling need not mean it is falling down only. It could also mean it is going up, but it is only under the influence of gravity. So the word, free fall. So the word free fall technically means the motion the motion is influenced by gravity alone. This is very, very important. And also keep in mind that your air resistance, if any, air resistance, which is technically going to be there, air resistance for now is going to be neglected, is basically going to be neglected. Okay, this is very, very important. In reality, obviously, air resistance will be there. It will definitely create some, difference. But for now, it's okay because we have to study fluid mechanics and there could be some complex integrals and functions which need to be solved if fluid resistance or air resistance is considered. For now, let's keep it. Coming back to the next point, the acceleration which happens due to gravity is constant. The acceleration, the acceleration due to gravity, the symbol for that is basically G. The symbol for that is G. It is 9.8 meters per second square, but we can approximate it usually as, yes, we can approximate usually as 10 meters per second square, or even pi, which is that constant in that circle, pi square meters per second square, because pi is 3.142. So if you square it, you will get close to 9.8. So these are the approximations which is usually used in most of the questions. So whether you throw a body up, whether you throw a body down, as long as only gravitational pull is there, it is considered motion in free fall. This is free fall. Even this is free fall. Even this and this is free fall. Even this is free fall. Everything which is just influenced by gravity is motion under free fall. And that acceleration, because the speed keeps on changing. It's not like when I drop, the speed is same. The speed will keep increasing. So every 1 second, the speed roughly increases by 9.8 meters per second. That's the increase. Also, please keep in mind that the acceleration due to gravity, this one is independent of the mass, is independent, is independent is independent of the mass, is independent of the mass. This is very, very crucial. So if I drop an elephant or if I drop an ant, both of them will fall at the same time. Obviously, air resistance is neglected. Okay? Yes, both of them will fall at the same time, assuming air resistance is neglected. It sounds very bizarre, right? Just imagine an elephant is falling, an ant is falling, a dog is falling, a human is falling, a dinosaur is falling, all of them will come at the same time. Mass has no relation over here. Okay, acceleration is the same. Is that clear? Okay, NLM will come in August or July end. Great. Now, having said this, let us take certain scenarios. There are three major scenarios in motion under gravity, 1D motion. First is when you drop it from the top, second is when you throw it from below, and the third one is you throw it with some speed from the top. So we'll see all these three scenarios. So first is object is projected from the ground. That means you throw it from below like this. It goes up, stops, and returns and comes back. So just imagine this, guys. This is some object. Okay, my headphones I'm throwing, I'm sacrificing it for the sake of physics. So I take this and throw it on the top, it goes and comes back. I throw it on the top, it goes and comes back. I throw it on the top, goes and comes back. I throw it with more speed, goes for a longer duration and come back. Throw for a smaller speed, it goes lesser height, lesser time. So in this kind of scenarios, you will notice one peculiar thing is that the speed which is there, the speed which is there where you throw it, the speed gradually reduces until it becomes zero, and then again it starts coming down with the same speed like this, the same speed like this. So at the topmost point, you will notice that the at the topmost point, the velocity is zero at that instant, at that instant. But do not forget, but acceleration is still going to be g, which is not zero. Acceleration is always going to be there. This is a very unique example. There are questions, statement based questions like when velocity is zero, acceleration is zero. It's wrong. If velocity is zero for a moment, does not mean it is not accelerating. Yeah, at that moment velocity is zero, but next moment it will gain some new velocity. So during that duration, obviously it has changed velocity, it will have acceleration. So no point of time the acceleration vanishes, it is always present. Okay, it is always present. Also, you will see that the upward and the downward motion is symmetric. The upward and the downward motion, the upward and the downward motion is symmetric. Upward and the downward motion is symmetric. Meaning, whatever time it takes, let's say 3 seconds to go up, same time 3 seconds it will take to come down. If it takes 7, it will take 7. So 7 plus 7 will be 14. 14 seconds to go up and down. Same way, if the speed was 7 here, after it comes back here, it will be 7. If the speed here was 4 meters per second, this same level, the speed will be 4 meters per second. So the speeds are obviously going to be the same. So if this is u speed, this is also u speed. If this is v1, this is also v1. If this is v2, this is also v2. At the same height, same speeds will be there. But yes, obviously direction will be different. And we can also say the time taken to go up is also the time taken to come down, is also the time taken to come down. So the total time will be 2 times the time taken to come up, or 2 times the time taken to come down. That is very obvious. Everybody clear? Give me a thumbs up till this point. Why is the motion symmetric, if somebody might ask? The answer is because acceleration is same. Whatever happens while going up, same acceleration is there. Same way it will do the same things. So same changes in speed every second, but yeah, direction will be opposite. Clear, everyone? I hope this is absolutely clear. And yes, please solve Tattva or any coaching module, whatever you have. Preferably, if you have Tattva, please use it. I mean, the Tattva modules are really, really amazing. It has not only the theory part, it also has the precise points. It has got everything in it. It's got previous year questions, level wise questions, everything. So please solve it. It's got even difficult problems over and above your competitive exams, along with the previous years with the solutions. So please solve them. Right. Now let's derive certain things over here for motion under gravity when you throw it from bottom. So let's say I throw it from the bottom like this, and it goes up till here, stops, and again comes back over here. And this is the level from which I throw it. This is the level from which I throw it. The speed is basically u. And at the topmost point, obviously, the velocity is zero just at that moment. Acceleration due to gravity, if you ask me, it is going to be downwards. So I'll show that vector, and that vector will be g, acceleration due to gravity. Fair enough. Now let's try to find a couple of things, starting off with how much is the maximum height reached. So what is the maximum height which it reaches? Let's say I call that as h. How do I find this out? How high will the ball be? If it has to reach on the top, so I'll consider the upward motion maybe. So considering the upward motion, so consider the upward motion, consider the upward motion, and I want height, which is kind of displacement. So I need S in the equation. I have three equations. V is u plus at, no use. S is ut plus half at square, I don't know the time. V square is u square plus 2s, kind of makes sense. So if I use V square is equal to u square plus 2 times acceleration into displacement, the final velocity from here to here, this is final, this is initial. Final velocity is 0. Initial velocity, well, that is u. U is the speed with which I have projected it. So u is nothing but the speed of projection. The speed of projection. The speed of projection. Now, when I say speed of projection means when I throw anything up, it's the speed with which it leaves my hand. Don't say, sir, when I was holding it, the speed was 0. How come it is having u? See, obviously, I'm holding it, the speed will not be there. But when I throw it, when I'm about to release it, and it departs or it detaches from my hand, that time, whatever speed is there, that is u, which is speed of projection. Okay? All right. Very good. Awesome. Awesome. Now, next important thing over here is what is that acceleration? Think about it carefully. Acceleration is downwards, so we need to assume something positive, something negative. So if I take upward direction as positive, it is obvious downward direction will be negative. So acceleration due to gravity will be negative g. Negative g. As you go up, obviously initial to final displacement is upwards, so displacement is positive h. This sign convention is very important. If you miss it, you will get some weirdness. You will not get some good answer. Anyways, now bring this over here. So you will see 2gh is equal to u square. Therefore, taking square root, root of 2gh is equal to root of u square. So therefore, u is nothing but, or actually I don't need that. I just need h. So just rearranging, h will be nothing but u square divided by 2g. This is a very nice formula. Height is u square divided by 2g. So say for example, if somebody, okay, takes a ball and throws it with 40 meters per second, I want to know what height till it goes. That height will be u square by 2g. U is 40, square it, divided by 2 into gravitational acceleration. Gravitational acceleration, let's take it as 10. 40 square is 1600. this will be nothing but 20, 0, 0 cancels. 160 by 2 is nothing but 80 meters. So 80 meters high, the ball will go. The ball will go 80 meters high when you throw it with a speed of 40 meters per second. That's how you can directly use this particular formula, u square by 2g. Sir, this is amazing. What about the time of flight, sir? What about the time of flight? Let's see. So capital T, which is the time of flight, which is also 2 times the time taken to go up or 2 times the time taken to come down. Anything will work. So how do we find this total time of journey to return back to the same point? Let's think. V is u plus 80. Maybe I can do that because I know one thing, that the final velocity is just like this. This is final. This is initial. So if you consider the entire journey, so if somebody consider the journey, entire journey, final velocity is initial velocity plus acceleration multiplied by time. First kinematic equation. Final velocity is down. Okay, let me see what my sign convention says. Upward, I can choose to be positive. Downward, I can choose to be negative. There is no harm in choosing downward positive, guys. Then everything will be, whatever is positive will become negative, whatever is negative will become positive. It's like multiplying that equation with -1. So don't think, sir always took upward positive, I have to always choose upward as positive. Nothing like that. You can choose downward also positive. So in this scenario, when I choose upward positive, final velocity, think about it, it will be nothing but negative u. Initial velocity is upwards, same upwards is positive, so it will be plus u, plus acceleration. Acceleration is down, that means it will be negative g multiplied by time. If somebody had chosen downward as positive, upward as negative, for them final velocity will be plus u, initial velocity will be negative u, acceleration is down, which will be positive then, into time. It's like multiplying this equation with -1. So like I said, equation will not change, your interpretation has changed, but answer will be the same. Is that okay, everyone? Absolutely clear? Okay. Yes, the gravitational force will always act along the vertical direction. There is no horizontal, component or horizontal effect of gravity. Okay, so let's solve this particular question. As you can see, I can just take GT over here and take U over there. So minus GT will become plus GT, and this time is no any ordinary time. This is the total time. So therefore, it will become G capital T is equal to U plus U. So this will become 2U is nothing but G multiplied by T. So total time is 2U divided by G. Very important formula again. Time is 2U by G. So in this particular example, had I been asked to figure out what is the total time of flight, then the answer will be 2U divided by G. 2 times initial velocity was 40, G is 10, 0, 0 cancels, 2 4s are 8. So 8 seconds. That means 4 seconds to go up, 4 seconds to come down. So after 4 seconds, it will be at a height of, I think, 80 meters. And after 4 more seconds, it will come back to its original level. That's how you solve these kind of questions. Is that fair enough? Shall we do some questions based on this? All right, shall we do some questions based on this? Okay, so let's see. A ball is thrown up with a speed of 15. How high will it go before it begins to fall? Come on, everybody spam the answer in the chat box. So some people might be saying C, some people might be saying A, B, and the correct answer is option A. How do we get that? See, if it is thrown with this speed, how high will it go? That means height is asked. That means u square by 2g formula I will use, which I've just told you. Speed is nothing but 15. So 15 square divided by 2 multiplied by g, which is roughly 10. 15 square is 225 divided by basically 20. Okay, so this will be 22.5. 22.5 divided by 2, which is nothing but 11.25 meters. So hence the correct answer is option A. Very good. Excellent. Yes, take approximately G as 10. That will be a good approximation, right? This kind of question should be solved in barely couple of seconds. Next question on your screen. Here it is. A juggler. Juggler means you take some object, you throw it before it reaches your hand. You throw the next object, then you throw the next object. You can have 3, 4 objects going like this. Okay, one object is here, next object is thrown, this goes here, and next object is thrown, and then you catch this, and then you throw it again. So that is juggling. And you throw it at equal intervals with the same speed. So with the same initial velocity, when the first ball reaches its highest position, he throws the next ball. Oh, assuming the juggler throws n balls per second, the maximum height the balls can reach is how much? Okay, so assuming the juggler throws n balls per second, the question is, how much is the maximum height the balls can reach? Now, say guys, one information is given that when the first ball reaches its highest position, then he throws the next ball. Okay, that is one kind of information which is already given to you. So say for example, you throw the ball with some particular speed. Okay, it reaches this particular height. This height, when reached, then you are throwing the next ball, and h is related to u, given by the formula u square by 2g. How much time it takes to just go up? Well, the time taken to go up is just u by g. And assuming the juggler is throwing n balls per second, that's the frequency. Think about it. What will be the time interval? What will be the time interval? What will be the time interval between the balls? What will be the time interval between the balls? I think it will be 1 divided by the frequency. This is a standard formula which you should know. Some of you will learn this in circular motion, simple harmonic motion, or even wave motion. But some of you might remember this particular formula from 9th or 10th standard. Time is inversely related to frequency. Frequency is the rate of doing things per second. Time period is the interval between those events. So the interval is 1 by frequency, or frequency is 1 by the time interval. So clearly the frequency has been given to be 1 by n, and this time interval is exactly the time taken to go up. This time interval is exactly the time taken to go up. So therefore one can say 1 by n is nothing but u by g. Therefore, u is equal to g divided by n. So u is equal to g divided by n. Because these are equal, these two are equal, u by g is equal to 1 by n. So u is g divided by n. So substitute that over here, u is g by n, and see what do you get. U is nothing but g by n the whole square divided by 2g. So this will become g square by 2g, and this n square will be there. G will cancel, so you'll be left with g by 2n square. So g by 2n square, which is a D option, is the perfect answer. Awesome. Yes, D for your Diksha ma'am. Perfecto. D option. Amazing. Couple of you, I guess, got it right. Very good, guys. Very good. Yeah. Yeah, 12th standard classes will happen at 8 o'clock. Please keep that in mind. Okay. Now, let's do the next variation. There are going to be mixed problems also. First, let's see the three variations, and then we'll come to the mixed questions. If you drop the object from the top, then what is the outcome? So, see guys, what will happen is you drop it. Dropping means you throw it with 0 speed. Slowly the speed increases, and with some nice big speed, it will probably hit the ground. So this is the speed of impact. This is the speed of impact with the ground or the floor or whatever the foothill is. And whenever you drop something, so dropping means that the velocity initially is zero. The dropping means initial velocity is zero. And slowly the speed increases before it ultimately touches the ground down here. So let's see formulas which are required. Well, so starting off with, well, you are dropping. So since you are dropping, that means initial velocity will always be zero, and you are coming along this particular path like this. Eventually, you will hit the ground over here, and the final speed of impact is, let's say, v. Okay, this is the surface at which you are probably hitting, and the height is also given to me from which you are dropping it. This is the height of the tower, hill, or maybe aeroplane is dropping something. So that height is also given to me. So let's start finding out different things. Let's start finding out different things. Oh, also remember that the acceleration due to gravity is going to be downwards. Now one might argue, shall I take upward as positive or downward as positive? It kind of makes sense that everything is happening towards the earth. So might as well take everything that is pointed towards the earth as positive, because unnecessarily we'll avoid the negative sign. It's just a matter of convenience. There is no hard and fast rule. So as per my free will, I am choosing the downward as positive and upward as negative. There is no hard and fast rule. Please remember that. It's just that if I choose upwards as positive, everything will be negative. It's just like multiplying the equation with -1. Equation will be still producing the same result. Is that okay, everyone? All right. So let's start one by one. What is the speed of impact? So in order to find that, height is known, initial speed I know, acceleration I know, time I don't know. So third equation. So if I use the third kinematic equation, which is v square is u square plus 2 times the acceleration into displacement. Final velocity is v, initial velocity is 0, acceleration is down but positive, so plus g. Displacement is down and downwards is positive, so the downward displacement is plus h. Perfect. So v square is 2 times gh. Therefore, v is root 2gh. Root 2gh. Very important formula. V is root of 2gh. Just to give an example, imagine there is a cloud, okay, and this is a drop of rain. This is a drop of rain. By the time, let's say, it reaches down over here, let's say this height is 45 meters. I want to find what speed will it fall down by. Okay, it falls by height of 45 meters. Chumma taking some random value. So this will be root of 2gh. So G value is nothing but 10. Height is nothing but 45. So this will be nothing but 45 into 2 is 90. So 90 into 10 is 900. 900's root is nothing but 30. So 30 meters per second will be the speed of impact. 30 meters per second will be the speed of impact. Yeah, very good. That's how you get it. Sir, can we also figure out how much time will it take? Why not? In order to find the time of fall, I know displacement, I know speed, I know acceleration. S is ut plus half at square. So if I use S is ut plus half times acceleration into t square, downward is positive, displacement is positive, so it is going to be positive h. Initially it is 0 speed, half into acceleration is positive as per my assumption, so it will be plus g. Time I do not know. In fact, I will call that as capital T. So this is the time for fall. Okay, so therefore h is g t square by 2. Therefore t square is 2 into h. G will come down. Therefore, time, I have to take a root symbol over here. So root of 2h divided by g. Root of 2h divided by g. So that is the final answer, root 2h by g. So we can use that same formula maybe to find this particular answer out. How much time does it take to fall? So time will be root of 2h by g. So 2 multiplied by 45 divided by g, which is 10. 45 into 2 is 90. So 90 by 10, which is root 9. Root 9 is 3 seconds. So it takes 3 seconds for the raindrop to fall down if the cloud is at just 45 meters, which is not much. Yeah. Is that okay? So remember all these formulas, guys. Yeah, all these formulas, please, please, please remember it, because you will otherwise waste time in the examination to derive it. Okay, I've just shown you direct application. Let's solve more questions so that you guys get some confidence. Here comes the question. A body is falling under gravity and it is covering a body is falling under gravity is covering 2 points A and B separated by 80 meters in 2 seconds. The distance of the upper point from the starting point is how much? Distance of the upper point from the starting point is how much? Interesting question. So let us visualize the question. That will be better for all of us. Okay. So imagine this. These are the 2 points. Let's say this is A. Let's say this is B. The other part, which I'm not really sure what has happened here. So maybe we can call this point O. Okay, like this. Throughout the journey, let me take downward direction as positive. Acceleration due to gravity is also going to be downward. At point A, there will be some velocity which I do not know. I will call it V1. At point B, I do not know. It will be some velocity V2. This distance is basically 80 meters. This 80 meters is covered in a matter of 2 seconds. That is what is mentioned. 80 meters in 2 seconds. So the question is, what is the distance between A and the starting point? Distance between A and the starting point is what the question is. Okay, let's try to think. If somehow I can find this speed, maybe I can find this displacement. I will call that as x, and x is what has been asked. I know one more thing, that initial velocity, or basically since it is being dropped over here, if you drop over here, that means the velocity at this particular position is 0. So how do I find V1 is the question. Maybe for this journey, I know the distance, I know the time, I know the acceleration. I can use the second kinematic equation, guys. What is it? It is S is ut plus half acceleration into t square. Displacement is 80, which is positive because it is down. Downwards is positive. That's what my assumption is. Initial velocity, don't take this because I'm only considering this journey. This is the initial speed for this part of the journey. Is that clear? For that part of the journey, what's the initial speed? Don't take the total initial speed. Okay, initial speed is v1. Time taken, I know, is already given to be 2 seconds. So best. So acceleration is, let's say, 10 and t is nothing but 2. Okay, let's see what happens now. So 80 is equal to 2 times v1 plus 2 and 2 cancels. 2 into 10 is 20. So 80 minus 20 is 60. So 60 is 2 times v1. So therefore, v1 is 60 by 2, which is nothing but 30 meters per second. Okay, I have got the speed here. How do I find this distance? Again, I can use v is u plus 80, but that will give me just the time. Or s is ut plus rpt square will talk about initial speed. V square is u square plus 2s, I think makes sense. So how about using v final square is v initial square plus 2 times acceleration multiplied by the displacement. I think that will be better. Final velocity for this part is this. See how the same speed is final for this journey, but it is also initial for this part of the journey. So that can happen when transitions happen. So you are taking a big problem and you are dividing into parts. So this part's final might be other parts initial. Getting my point? So for this part of the journey, this is V1 is the final velocity. So that's how you need to be careful. Initial velocity is this guy, dropping part, 0. Acceleration is plus g. Displacement, I do not know. Perfect. And g value obviously is going to be 10. So 10 into displacement, which I do not know. So what is V1? V1 is nothing but 30. So 30 square is 20 multiplied by x. 30 square is 900 is nothing but 20x. So therefore x is nothing but 90 by 2. Therefore x is nothing but 45 meters. So this part of the journey is nothing but 45 meters. Amazing. Loved it. Yeah. Okay. Can we get formula of V1 by some other method, some direct formula? There is no direct formula for V1 because see, whatever formulas I gave you over here are directly for initial speed being 0. So all these formulas are when initial speeds are 0. Keep that in mind. So for this particular question which we are solving right now, keep in mind that initial speed here is not 0. So I cannot say v is root 2 gh. No. Here I can say v is root 2 gh. Yes, definitely. For that green part I can use v is root 2 gh. Definitely I can do that because initial speed is 0. Not for this yellow part. Only for the green part I can apply formula. Okay. I hope this is absolutely clear. So if you are wondering, can I also solve this particular part? Can I solve this particular part with some direct formula? Definitely. I can say V1 is root of 2GH. So V1 is 30 and G is basically 10. Height is basically X. So basically 30 square is 900 is 20X. Therefore, X is 45 meters. So using this also for this part, you can do it. I hope everything is clear. Yeah. All right. Definitely. We'll put up plans. Yeah, definitely. All right. Moving now to the next question. There is a tennis ball which is dropped from some height of 9.8 meters. It rebounds to some height. If it comes in the contact with the floor for 0.2 seconds, the average acceleration during the contact is. Very different kind of question. See, guys, very different kind of question. What is happening? Let me draw over here. First time it is dropped from some bigger height, but it rebounds to a smaller height. Okay, no issues. So when you drop it over here, the velocity will be 0, and when you goes on the top, also here the velocity will be 0. So maybe this particular height is already given, 9.8 meters, and next time 5 meters. So this is basically 9.8 meters, and this is basically 5 meters. So when it hits the ground with some speed, but it rebounds with some new speed. But with whatever speed it rebounds, it is also obvious that after going up and after coming down, it will come back and hit the ground with that same speed of V2 because of symmetry. So it's as if dropping the ball from height of 5 meters, and how much will be the speed? It's the same speed with which it will rebound. I hope this is clear. And the rebound speed is less because maybe some energy was lost in the process. Okay. Everyone, fine. So how much is V1 and how much is V2? Let's find out that first. V1, as per the formula of root of 2GH. So it will be 2 into G, which is 9.8 multiplied by 9.8, which is 9.8 squares root is 9.8 root 2. That is V1. What is V2? Same formula, root of 2, G is 9.8. Sir, how did you decide G is 9.8? It kind of common sense, guys. Why else will they give the height as 9.8? Think about it, no? Logically. Why else will they use such a specific number? So when such things happen, use your common sense. Don't argue. Sir, it was not given in the question. I want bonus. I will protest in New Delhi. I will go to NTA and I will smash windows. I'll do this. No, don't do all such nonsense. Okay? Use your common sense. Okay, into height. Height this time is 5 meters. So I'm considering this part of the journey. because this part of the journey is same as this part of the journey. Whatever happens here will happen here, just in the opposite direction. Fair enough. 2 5s are 10. So it is nothing but, I would say root of 98, or you can just say root 9.8 root 10. That's what you can say. Now read the question carefully. It says find the average acceleration during the contact. Find the average acceleration. Acceleration average is nothing but final velocity minus initial velocity divided by the time interval. Here, the final velocity is nothing but v2. Initial velocity is not v1, rather it is negative v1 considering the direction, and time interval, I'll just put it over here. So technically, v2 is nothing but root of 9.8 multiplied by 10, minus minus is plus, and then you have 9.8 root 9.8 root of 2, whole thing divided by the time interval is nothing but 0.2. The time interval is nothing but 0.2. Yes, this is what it is. Everyone with me on this? Absolutely clear. If you want to solve this, well, you can take root 9.8 into 2 common, root 9.8 into 2 common, and what will be left is root 5 over here, because 10 is 2 into 5, 2 is here, so root 5 is here, and here 2 is already taken out, 9.8 is taken out, so it will be just root of 9.8 over here. This whole thing divided by 0.2. 0.2 is nothing but 2 divided by 10, so 10 will go on the top. So if you want, you can cancel this root 2. So it will become root of 9.8 by 2, and this will be root 5 plus root 9.8. This whole thing will be multiplied by 10. So if you find out that value after calculation, it will come close to 45. It will come close to basically approximately 45 meters per second square. But this is how you can do it. Is this absolutely clear, everyone? Okay. Rather, you are throwing it with some speed, either up or down. So in situations, remember, always use sign convention and kinematics. First thing is use sign convention, and then use kinematics. There is no direct formula, kinematic equations. For example, in this particular scenario, if this speed is u, the height of the tower, let's say, is h, and somebody decides upward direction is positive, and we want to say figure out what is this velocity or what is the time, etc. So if you use the third kinematic equation, which is vf square is v initial square plus 2 into acceleration into displacement. Keep in mind, acceleration is downwards, which is like this. So it will be negative. Final velocity is v. Initial velocity is u. Acceleration is negative g. Displacement, be careful. How many of you are thinking it is h? That is wrong. If upwards is positive, downwards will be negative. It is gone from here to here. Yes, the displacement is negative h. Sir, but it went up and then came down. I know. Everything has to be taken with the sign convention. Number two, s is always displacement. So never ever put this total distance. That's a common misconception. Always S stands for displacement. This was initial, this was final. The shortest distance, that is basically h. And that will be negative h by the sign convention. Everyone? Similarly, if I use, similarly, if I use S is ut plus half at square, S is ut plus half at square. Displacement is again negative. Initial velocity is positive. So it will be plus ut plus half into acceleration being negative g into t square. So that's how I can use the second kinematic equation as per the given situation. Lovely. Got it? Did you understand why S is minus H? Sir, but won't it give me wrong answer, sir? Because first it is going up and coming down. Don't worry. The kinematic equations knows this, and it knows this because you're following the sign convention. It knows it that, oh, displacement is negative. That means you have come down. Oh, the initial velocity is positive, so it is plus. So it accommodates automatically. That's the beauty of maths. It accommodates automatically. Oh, I have to first go up and come down. So there will be a lot of time over here. So it knows that, okay, I have to consider some time to go up and come down. So mathematics will take care of it. If that same velocity was down, if I throw it forcefully down, then this plus ut will become minus ut. So the time answer will be completely different. So everything will be taken care of by sign convention and rest by the mathematical equations. Got it? Absolutely. So don't think that you're missing out on any time or missing out on data or information. Everything is fine only. Okay, let's do this. A stone is thrown up from a height of 25 meters at this speed. How much time does it take to reach the ground? So let's draw the situation. This is given to be this is given to be 25 meters, and you're throwing it from this height at a speed of 20 meters per second. So obviously it will go up and then it will come down over here like this. Okay. During this motion, obviously acceleration due to gravity will be down approximately 10 meters per second square. We can take downwards or upwards as positive. Let me choose upward as positive for now. Let me solve this equation. I think we have to find the time. So maybe it makes sense to use the second kinematic equation because it has displacement, speed, acceleration, time is not. So let's use S is ut plus half at square. Check it one by one. I started from here, ended here. Initial to final displacement is down. Downwards means negative. Okay. So it is minus 25 meters. Initial speed is up, so positive. So 20 multiplied by the time plus half into acceleration. It's down, so definitely negative. So minus 10 into t square. As you can very easily see, 2 and 2 and that 10 cancels, it will become minus 5. Perfecto. So we can cancel 5 from everywhere. 25 by 5 is minus 5 over here. 20 by 5 is 4t minus 5 is gone. So t square, looking like a quadratic equation. Might as well shift t square here. So minus 40 minus 5 is 0. Minus 5 plus 1, that will be the factorization method. So t minus 5 and t plus 1, because minus 5 into 1 is minus 5, minus 5 plus 1 is minus 4. So using the factorization method, this is 0. So either this is 0 or this is 0. So that means t minus 5 is 0 or t plus 1 is 0. So that means t is minus 1 or t is 5, one of them. But it is obvious now, this has to be correct and this has to be wrong because time can't be negative. Time value can't be negative. That means you have gone in the past. So that means everything is happening in the past. That means it reaches here in the past. Oh my God. How can you throw a ball and it reaches here in the past? Doesn't make sense. So this is the only valid option. So 5 seconds is option number A. So whenever you get such quadratic equations, always see which value makes sense. Does both value make sense, etc. Okay, you have to always visualize. Okay. So keep this in mind, this particular fact of negative displacement or positive displacement. Just to give you one more time heads up on this. See, if you consider this journey, it goes like this, it goes like that and comes over here. Okay. This is initial, this is final location. Now, if somebody chooses upwards as positive direction, we know first of all, the displacement is like this. This is the displacement vector. This is displacement vector from initial to final. Head, tail, right? Tail, head thing. So obviously, somebody choosing upwards as positive, the vector of displacement is negative. So displacement is negative here. But somebody chooses downwards direction as positive. So for them, downwards is positive. So displacement will be positive value. Is that making sense, everyone? Now, clear? Yeah. When to take displacement negative or positive, it's completely a sign convention, a matter of choice. So here I've chosen upwards as positive. So displacement is negative, but initially I've thrown up. So because I put U as positive 20, this time takes into account that the ball will first go up and then come down. Okay, so it knows when we solve mathematical. Mathematics will take care of the rest. Okay, everyone. So this particular time is considered. It's not that, sir, you only took displacement. So I think only you got this much time. You have to add this time. No, no, no. I don't have to add, subtract anything. Everything is automatically taken care of. I'm very good, guys. I hope you guys are doing extremely fine. And if you have not yet marked the attendance, mark it. Yeah, like the video. Okay, doing it all for you, all the 2026, 2027 aspirants, especially the 11th students. You have 2 years, and the 12th or the dropper students, please watch these classes so that your backlogs are covered on time. And daily classes, 6 o'clock for 11th syllabus and 8 o'clock for 12th syllabus. I mean, what more you can ask for? Imagine. All right. So moving on to now the next question. This is another interesting question. There are some water drops which are falling from a nozzle of a shower onto the floor from a height of 9.8 meters. The drops fall at regular intervals of time, and when the first drop is striking the floor, then the third drop is just beginning to fall. Locate the position of the second drop from the floor when the first drop strikes the floor. Oh my God. Let's draw the scenario. This is the scenario. This is the path of the drops. This is the flooring. Okay. So this is the third drop, and the velocity over here will be 0. The first drop will be hitting over here. This is the first drop is touching the ground with some speed, and meanwhile, the second drop will be somewhere over here. The second drop will be somewhere over here. The time gap will be the same. Yeah, whatever time is between second and first drop, same time between third and second drop, because every interval, tup, 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 water is leaking. Tup, that's water came, and second drop also came, and then the third drop is just about to leave. That time the first drop is just about to reach the ground. Second drop is somewhere in between. That's what it is. Okay, welcome everyone. Welcome everyone. Okay, 9th standard kids should not say that they have backlogs as of now. If you have backlogs, then I don't know. Maybe we should start our competitive exam preparation when you are in LKG, UKG only. Next video will be, I am in LKG, I have backlogs. What do I do? Don't worry, I will help you. Okay, so now what do we do over here? Total height is given. Okay, bro. Total height is given. This total height is 9.8 meter. So probably for a reason, because G has to be taken as 9.8. So if I consider the total time of flight, the total time to fall, there is a formula, root of 2h by G. So 2 into 9.8, G value also 9.8. So therefore, time will be basically root of 2 seconds. From here to here, it takes 2 seconds. So can you guess what is the interval between every drop? What is therefore the time interval between the drops? Between the drops, let's say I call it small t. let's say I call it small t. I think it will be total time by 2 because this is one interval, this is another interval. How? The first drop is, let's say, here. First drop right now is here. It starts falling down. Now second drop comes, it reaches here. So t seconds are over. Then the second drop is over here. First drop is over here. And t seconds, small t seconds are elapsed. So once this reaches here, then the next t seconds are over. So 2 times small t is over from here to here. That means small t is capital T by 2. So root 2 by 2, which is 1 by root 2 seconds. Or just look at it like this. Here to here is one time interval, small t. Here to here is one time interval, small t. So t plus t will be total time, which is root 2 seconds. Total time of fall starting with 0 speed using the formula root 2 h by g. Yeah, don't divide by 3. That's the most common mistake. People think there are 3 drops, so divide by 3. So if there are 1, 2, 3 people, so 3 people, if you see between them, the space will be divided in 2 parts. Think of it like that. One person, second person, third person. There is space between them and space between them. So there are 2 spaces between these people. So that's how you should look at intervals. Is that clear? So lot of people make that mistake of miscounting by a factor of 1. Okay, now once we get this, I think we can figure out how much is basically, this much height. So we can find this x. So using s is ut plus half at square, or we can use t is root of 2h by g also. So up to you. You can use s is ut plus half at square. We can take downwards as positive, no harm. Displacement is x, u is 0, plus half into acceleration is 9.8. Time from here to here is this much. So 1 by root 2 whole square. So this will be 2 basically. So it will become 9.8 divided by 4. X is 9.8 divided by 4, but that is not the question. The question is only something else. The question is how much high is this drop from the ground? So find the position of the second drop from the floor. So that height will be the total height, which is 9.8 minus this height, which is basically x. So 9.8 minus 9.8 by 4, which is 3 by 4. 1 minus 1 by 4 is 3 by 4 times of 9.8. So 3/4 of 9.8, guys, how much will it be? Come on, quickly tell me the answer. Yes, quickly tell me the answer. 9.8 divided by 4, close enough to our option number D. Yes, 7.35. Very good. Option number D, 7.35 meters. Perfect. 7.35 meters. Yeah. Now you can easily eliminate the options without even calculating. Just think about it. I mean, like 3/4, that's 75% of 98. 3/4 is 75% of 9.8. 99.8 is like, think of 98 number, which is close enough to 100. So 75% of 98 will be close enough to 7.5. So the only option close to 7.5 is 7.35. Yeah. So approximately get the answer. That's also enough. You don't have to find the exact values. A ball is thrown up with some speed. The ratio of the speed after 3 seconds and 5 seconds is this much. Find x. Ratio of the speed is asked. Okay. So first of all, let me use directly the velocity formula. V is initial velocity plus acceleration multiplied by time. So first scenario, ratio of velocity after 3 and after 5 seconds. So V3, I'm throwing it up with 150 meters per second. Acceleration, now please visualize this. My velocity is 150 meters per second. Acceleration is downwards. I can take upward direction as positive. Naturally, downwards will be negative. So the ball will go up like this, maybe. That is how the ball is going up and down. Anyways, so now Final velocity, I don't know. Initial velocity is 150, acceleration is minus 10, time is 3 seconds. So it will be 150 minus 30, which is 120 meters per second. Meters per second. Now let's try to figure out V5. Initial velocity 150, acceleration negative 10 multiplied by 5. Minus 10 into 5 minus 50. So 150 minus 50 is 100. So 100 meters per second. Now the question is figure out the ratio. So V3 by V5, V3 by V5 is 120 by 100. 0, 0 cancels, 12 and 10, 2, 2 cancels, so 6 by 5. 6 by 5. If you write it in this form, it will be 5 plus 1 by 5. Therefore, x is nothing but the number 5. So x over here has to be found. That will be the number 5. Okay. All right. Yes, definitely. Yeah, the portions in our prime batches will be covered by around November time. So definitely, and when you are joining any of our prime batches, please remember all these English batches. We cover entire 11th and 12th syllabus. Not just that, we also give you those recorded repository of lectures. So in case you want to follow different schedule, you can watch those classes as well. That is another option. Obviously, pro batches are there in pure English as well. If you want to take a drop, I would recommend you considering pro or offline, because pro has more mentorship. It has, obviously the modules, everything, hard copy is there, doubt solving is there, and many more additional things are there, which will make you feel very personalized, and um, you would get that kind of support which you would get in a proper offline institute. Also, if you are not willing to, or maybe you cannot afford that much money, then the prime batches obviously are the best option. You get all the quality content. Nothing like this is good, this is bad. It's completely matter of choice. Yeah, yeah. All right. Yeah. So, having said this, let's move, to the next question. Yeah, the answer was option 5. Okay, now going on to the next question coming up on your screen. There is a ball which is released from height h. If T1 and T2 are the time taken to complete first half and the second half of the distance respectively, first half and second half, choose the correct relation. Interesting question. Let's see. First half is this much and second half may be this much. So let's just say this is h by 2. Obviously, this is also h by 2. And of course, the total height was h. It started from rest. So it was dropped. Velocity was 0. Okay. T1 and T2 are the times. So this is taking time T1. This is taking time T2. Question is find the relation between them. Okay, let's try to figure it out. If you consider this particular part, I can immediately say, remember there was a formula which said time of fall, time of fall is root of 2 times height by gravity. Height by gravity. Yeah, just use this formula for this much part. So T1 will be root of 2 times h by 2, the whole thing by g. Okay, so square it. So T1 square, 2 cancels, is h by g. Is that right? Okay. So therefore, h is equal to g T1 square. Okay, this is one thing. Maybe I'll have to do something else also. Let's find it. If you consider the entire motion, total time is T1 plus T2. Keep that in mind. Entire motion. So the time of fall will be T1 plus T2 will be root of 2 times height will be total height by g, squaring both sides. T1 plus T2 whole square will be 2h by g. Okay, so g into T1 plus T2 whole square is equal to 2h. But what is h? What is this h, think about it. This h is gt1 square. Maybe good time to substitute it, gt1 square, because I want to find the relationship between t1, t2. G and g will cancel. Now, what I will do is take square roots on both sides. So, therefore, t1 plus t2 will be root 2 times of t1. Okay, t1 I can take it together. So, t2 will be root 2 times t1 minus t1. Therefore, t2 will be t1 common root 2 minus 1. So, t2 is root 2 minus 1 times t1, which is option D, of course. Yes, D for your Diksha ma'am. Perfect. Welcome aboard, everyone. If you are new to the channel, please subscribe. But I can see a lot of our old students only. Yeah, and if you are new, please don't be shy. Don't be hesitant. Please interact. Mark your answers. Spam the answers. Comment after the video. Yeah, participate. Like, subscribe, comment, help, everything, guys. Right? Okay. Let's go. Let's go. Let's go. Another question coming up on your screen. A body is thrown up with some speed of with a certain speed from the top, and it reaches in t1. If it is projected down, then it reaches in t2. How much time will it take if it is dropped from the tower? Wow, very nice question. Multiple variations are there. See, first time what is happening is I'm throwing the ball up with some speed. It goes up and falls down over here. Okay, it takes time t1 for this journey. So if I use our equation, s is ut plus half at square. Okay, and let us just assume that this particular thing, our displacement is downwards like this. It starts from here, goes down like this. Okay, so s is basically minus h, u is basically positive u, acceleration is negative g into t1 square. So u t1 plus half g1 t square with negative sign g because g is down. So I can say h is negative u t1 minus will become plus. So g t1 square by 2. That is the first set of equation which I got. Second time, I'm throwing it only downwards with that speed. It is going to start from here and displace this particular height, and it is going to strike the ground over here. This time displacement is again minus h. U is negative u because downwards is negative, upwards is positive. Time taken is t2 if you throw it down, plus half into negative g into t2 square. Minus 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 cancels. H is nothing but u times t2 plus half g t2 square. Okay, what can we do? If I just drop it, how much time will it take? If I drop it, I just need the height, but height is not known. How to get the height? Interesting concept. Let's see, what do we do? First of all, I feel LHS is equal. So since LHS is same, let's equate the RHS. Let's equate the right hand side. So the right hand side over here is negative u t1 plus g t1 square by 2, and over here the right hand side is u times t2 plus g t2 square by 2. Okay, let's see what can we get. Let's shift this over here. Let's shift this over here. So it will become g by 2 t1 square, and this t2 square will be minus is u, and this will be t1 goes on that side becomes positive t1 plus t2. Is that right? So this is a square minus b square, which is nothing but a plus b and a minus b. That's it. Is equal to u t1 plus t2. t1 plus t2, t1 plus t2 cancels. Interesting. So g by 2 into t1 minus t2 is equal to u. Oh, so I got u. So how about substituting u over here? Okay, so let's do one thing. Let's substitute, let's substitute u, substitute u in h. So what will we get? What will we get? H is equal to, h is equal to, just check this out, minus u t1 minus u. What is u? U is basically this whole thing, which is g by 2 t1 minus t2. G by 2 t1 minus t2. Okay, that whole thing is basically u. That whole thing is basically u times of t1, times of t1 plus g t1 square, plus g t1 square by 2. Just check this out. This equation, I have taken the value of u and substituted here so that I get height. Why do I need the height exactly? So that I can find the total time to fall if I drop it. So let's see what do we exactly get over here. So therefore, h will be equal to, this will be minus g by 2, t1 into t1 is t1 square, minus minus is plus. So g by 2, t2 into t1 or t1 into t2. Just check this out. Plus g t1 square by 2. Oh, these both are getting cancelled. Therefore, the height is g times t1 t2 by 2. Oh, perfect. I think now I can get to the final answer. So the time to fall will be root of 2h by g. When you just drop it, that's the formula. So 2 by g is there. Height, I can get it from here, which is g times t1 t2 divided by 2. 2 cancels, g cancels. So it will be root of t1 t2 is the total time. Root of t1 t2 is the total time. Thank you so much, everyone. Yeah. So these kind of questions require that lateral thinking and manipulation mathematically. Otherwise, I mean, it's at the end of the day, S is, just imagine, just S is ut plus half at square. Nothing else is there. Physics ended in this part. Substituting the values is physics. That's all. After that, it's pure mathematics. Oh, I need the height to find the time when I drop it. But how do I find height? Height is not even given. Okay, I don't even know u. U is not given in the question. So I need to eliminate u. So solving these two equations by equating h, I got the value of u. Used mathematics. U, I took it over here. So from that I got h. So once I got h, I substituted. So it's not like I knew the solution or I know the method from before only. No, we have to go on the spot. We have to just start doing something. Maybe we'll hit a roadblock. Okay, we try something else. Luckily we don't. So fine, we get to the answer. Yeah. All right. Yeah. So if somebody is going to school and also many people ask this, can I join any online batch or prime batch, this batch, that batch? So I'll tell you one thing. Even if you had a batch which started at, let's say, 7:30, anything, how would you manage time? Because then that lectures will end at 12 o'clock or 1 o'clock in the night, because we need to deliver that content. So some people, what they do, they join some very crash kind of batches, which are like, oh, okay, I will teach you only 2 hours every day. Enough. Don't worry, you will get enough time. But then that is not enough to crack the competitive exam. Please understand that. So that's the reason why we need to go in detail. And whatever classes you miss, it's okay. You can watch the replay. How difficult is it to watch a replay? And the best part this time is that our replays also have the doubt solving facility. So you can ask any kind of doubts and you will get the answer. Still, if you have any query, our Telegram groups are there. It's quite open. You can ask anything to our teachers and students, right? So it's better to be a part of the prime batch, watching the replay, instead of losing out entirely and joining some random fast crash batches. Okay, great. So I think we have the last question, which is supposed to be our homework. So body is dropped from some height. If it is stopped after 3 seconds and again released, further time of descent is. So just to give you the hint, see total this total height which was there, that is basically 122.5 meters, and you are dropping from this point. So actually it would take many seconds to fall by the side, but in 3 seconds only you stop it. So it would have covered some distance. You can find it out. For that remaining distance, how much more time will it take? That's the question. So now I hope you have understood the question. So after 3 seconds, you stop it, see how much distance will it move. So subtract that distance from 122.5. That remaining distance, how much time will it take? Again, it starts from 0. So I hope now you'll be able to solve the question. The answer is there on the next slide along with the solution. So please check it. So that was your motion under gravity free fall. It's a very simple, sweet thing, but a lot of manipulations could be there. So obviously, next lecture we'll be doing calculus based questions. So if you have not yet checked basics of integration and derivative slopes and areas, please check that lecture. I will not be teaching again derivatives and integration. I'll be directly using it for non-uniform motion. Okay, so that will put an end to the motion in straight line. So see you guys. I hope you enjoyed the class. Smash that like button, and if you have not yet subscribed, subscribe it. Okay, you will get the PDF down in the description box. Bye bye. Take care. Have a lovely time.